Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 6H. Myself, Shashwat Munitripathi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presenters, and each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On ninth minute, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in a chat box. Just before we start this session, I would like to introduce you to the chair of this session, Dr. Deep Raj Chatterjee. Sir, Sir is an assistant professor in the Department of Computer Science and Engineer at Techno International Newtown, West Bengal, India. He has published numerous research papers across international journals, conferences, and book chapters. His research interest includes computer vision, deep learning, and software engineering, contributing to his strong academic and research profile. Welcome you to the session, sir. Would you like to share a quick opening remark with us?
Thank you, Shashwat. I welcome every participant in this ICTCS 2025, the 10th International Conference, which was held in Jaipur city. We give your best.
Thank you.
Yes, Shashwat, you can continue.
Okay, sir. So the next presenter was Venepusa, a paper titled Analytical Estimation of Electric Vehicle Battery Charging Duration Across Multiple Charger Level.
Sir, good morning, sir. Are you audible, sir?
Yes, you are audible.
Sir, my screen is visible, sir.
Yes.
Sir, good afternoon, sir. I am Surendra Reddy, and today I am present my research paper titled Analytical Estimation of Electric Vehicles Battery Charging Duration Across Multiple Charging Levels. The outline of this research are introduction, literature review, research gaps and objectives, methodology and system design, implementation, result and analysis, conclusion and future work, references, acknowledgement. The main motivation of this research: electric vehicles are key part of sustainable and eco-friendly transportation. They are help reduce carbon emission and dependency on fossil fuels. One major challenge faced by electric vehicle users in uncertainty in charging duration. Charging time varies depends on charging time, battery capacity, and efficiency. This uncertainty affects the user confidence and charging infrastructure utilization. This motivated us to work on simple and reliable charging time estimation approach. Literature review. Several studies have addressed electric vehicle charging behavior and performance. Some research is focused on battery degradation during fast charging, while other used simulation tool to estimate charging time. There are also studies comparing charging standards and optimization charging infrastructure. However, most existing work focused on individual charging levels or complex simulation models. This is research gaps and objectives. The existing systems studies provides useful insights. There is no simple analytical model that compares charging duration across all charging levels using a single framework. To address this gap, the objective of this study, we propose a real-time integrated framework. The framework includes a universal analytical model and decision support tool from infrastructure planning and smart grid energy management. This is for methodology. That methodology consists of four main components. The first component, universal analytical model, the estimated charging time using common parameters. The second component, efficiency adjusted estimation. This accounts for real world losses such as heat and power conversion losses. The third component, standardized frameworks, ensure fair comparison among level 1, level 2, DC and DC fast and ultra fast chargers. The fourth component, decision support tool that helps planners make informed infrastructure and grid management decisions. This is implementation. The charging time depends on required energy, charging power, and charging efficiency. This model is simple, easy to implement, and applicable to all charging types. We considered battery capacity of 60 kilowatts hour. The initial state of charge is 30% and the final state of charge is 100%. The charging efficiency is assumed to be 0.9, which reflects the real world charging conditions. So, the required energy to fully charging the battery is 42 kilowatts hour. The slide represents the experimental setup used to estimate EV charging time for different charging types. We assume a required energy of 32 kilowatts hour and calculate charging time using charging power and 90% of efficiency. Level 1 and level 2 AC chargers take longer charging duration, make them suitable for home and workplaces. DC fast and ultra fast chargers significantly reduce charging time, supporting public and highway charging needs. This comparison highlights the importance of selecting appropriate chargers for efficient and convenience of EV operation. Result and discussions using the proposed model charging time was estimated for different charger levels. The results show that charging duration decreases significantly as charger power increases. This table shows the estimated electric vehicle charging time for different charger types using the proposed analytical model. As charger power increased from level 1 AC to ultra fast, the charging time reduced significantly. This clearly demonstrates the inverse relationship between charging powers and charging duration. And this bar chart shows the charging time variation across different EV charging stations. Level 1 AC has the highest charging time, while ultra fast charging required the least time. The graph clearly highlights that the charging time decreases sharply as charging power increases. This is for conclusion and future work. This study presented a simple and universal analytical model for estimating EV charging time across multiple charging levels. The model considered battery capacity, state of charge, charging power, and efficiency. It provides realistic and accurate charging time predictions and enables standardized comparison of different charging systems. The future work of this research, it can be extended by integrating real-time data using vehicular ad hoc network, and machine learning techniques can be used to adapt charging time estimation based on battery health and temperature. And one more, vehicle to grid interaction can also be explored to enhance smart grid coordination and energy management. These are the references that demonstrate significant advancement in electric vehicle charging, routing, and optimization techniques. Collectively, they establish the technical background and motivation for the proposed vanity-based EV routing model. The finally, acknowledgement. I sincerely thank the organized committee of ICTCS 2025 for providing this opportunity to present my research work. Thank you very much, sir.
Thank you for the presentation. Sir, do you have any question?
Yeah, so Surendra,
Yes,
can you
sir.
tell me how to implement the idea of VANET in this charging field? You have given it in future scope, right?
Yes, sir.
So how you can use it? Can you tell me?
Sir, in previously there is no simple analytical model, sir, that only to calculate the duration of the charging across all charging levels. My present work to calculate estimation of all charger types and calculation duration of charging time. So the driver they can calculate and choose suitable charger, sir.
Okay, okay, perfect. Thank you.
Okay, sir.
Thank you,
Thank
Shah.
you very much, sir. Thank you, sir.
And the next we have Sandhya Rani, paper titled Deep Learning for Audio Quality Assessment in Music, Models, Metrics, and Challenges. The next presentation is Gurbaksh, the paper titled Dynamic and Personalized Interview Preparation System Using AI and NLP Technologies. So next we have Anil Kapoor. Anil, paper titled Effective Health Monitoring for Metal Oxide Surge Arresters Case Study.
Yes, sir. I will present this paper. Good afternoon, all. Just let me share my entire screen. Sir, hope my screen is visible. Hello?
Yes,
Hello?
your screen was visible. You may proceed.
So good afternoon, all. My paper surge arrestor, that is the effective health monitoring MOSA. So that's why we have mentioned over here the MOSA. And this paper is prepared by me and one of my colleagues, that is Mr. Umesh Soni. And we are working at Electrical Research and Development Association. And I am heading R&D and Expert Services Division and working as Assistant Director over here. So if we see some introduction, so we know the lightning arrestor is connected in the power system for the protection of electrical power system against the over voltages. These over voltages are caused basically due to the natural lightning or otherwise the switching phenomena. So to protect the equipment against that in the power system, the surge arrestors are connected in parallel with the equipment to be protected. Uh, these surge arresters are basically aged due to the after over period of time due to the temperature, humidity, because all these surge arresters are installed in the open atmosphere. So environmental condition will also affect on the condition of the musas, and also few operating conditions like a number of lightning strokes will be there, which will be bypassed through the surge arresters. So all these parameters affects on the musa's health monitoring, healthiness of the musa. So what people are doing that every year they conduct few tests to check the healthiness of the Musa. Not only the Musa but other equipment also the people are performing some condition monitoring test. When we talk about the surge arrestor, then surge arrest for verifying the health of the Musa, we generally measure the leakage current. And this leakage current is divided into the two part, that is the total leakage current, which is again bifurcated in the capacitive current as well as the resistive current. So if we see the equivalent circuit of the Musa metal oxide surge resistor, there are two parallel paths are there. One is the resistive component and another one is the capacitive. And since there are two parallel paths, one is resistive and capacitive, the current is also divided into the two parts, that is the resistive current as well as the capacitive current. So whatever current passing through the surge arrestor, that is which normally we call as a total leakage current. So it is divided into the two category, IR and IC. And since there is a phenomena of the electrical well-known fact that when there is a capacitive current, it is always lead by the voltage by 90 degree. So the phasor diagram also shown over here to understand how the current phasor relation of the currents and voltage. The surge arrestor failure mechanism I have shown over here. So as I told you, the metal oxide surge arresters are moisture ingress is there, then surge duty is there. So number of lightning surges are impact on the surge arresters. Then aging effect is also there, as well as some temporary over voltages are also there in the system. So all these parameters are affecting on the surge arrestor conditions. So what will happen that it will increase the leakage current of the surge arrestor due to all these environmental effects and aging effect. And as a result, what is happening that when the current is increasing, the temperature of the surge arrestor is also increasing. And since the temperature is increasing, the resistance will get reduced, and as a result, the current will further increasing. So these all happens, and because of that, the surge arrestor will turn into the thermal runaway, and which is the basic reason to failure of the surge arresters. So if we wanted to safeguard the surge arrestor or system, so we should always avoid the thermal runaway condition. And to avoid that, we need to check the healthiness of the surge arrestor at equal interval. These are the technique by which we monitor the healthiness of the surge arrestor. We can see over here one surge arrestor has been connected over here, and this one is the surge arrestor which is mounted on the metallic structure, and here there is a current transformer is connected, which is a part of the equipment, and this one is the equipment leakage current measuring instrument which measure the leakage current flowing through the surge arrestor. One field probe is also connected over here because whatever the harmonics are there in the supply, it has to be bypassed or it has to be nullified. Otherwise, those harmonics may affect, result into inaccurate readings of the measured leakage current. So that is why this field probe has been connected. So this is how we measure the leakage current flowing through the surge arrestor, and we see the trend analysis of the leakage current, and based on that we decide the healthiness of the surge arrestor. So here two case studies we have shown here. So one case study is of 220 kV surge arrestor. So there are number of surge arresters well connected in the substation. So we have measured the six surge arresters of 220 kV rating, where we have measured the total leakage current. So the unit is in microampere peak. So we have measured first reading on 2023. Then after 1 year in 2024, again the same measurement was carried out on the same surge arrestor, and then again, third year, that is this year 2025, again we have done the measurement of the total leakage current. So if we see, these are the trend analysis that first year it was 545 some microampere, then 568, and then it increased to 654 and so on. Only thing here we need to see the lightning arrestor surge number for that MOSAS 4 and MOSA 6. These are the results where little bit abnormality is there. That initial measurement of somewhere 600 micro, 608 microampere. Then this year, after 2 years, it was increased to 1559 microampere. Similarly, for the sixth number of surge arrestor, the initial measurement of 878.5, and this year, after 2 years, it increased to 969.4. So these are the trends are very much increased. Similarly, the resistive current flowing through these of both the LS, like MOSA 4 and MOSA 6, that is initial reading was 69.6 microampere, whereas this year, after 2 years, it was increased to 135.8. Similarly, for MOSA 6, it was initial reading was 63.3, and then this year, when we measured, it was tremendous, almost three times it was increased, that is 168.1 microampere. So these are the trend analysis, is a graphical representation which just we have spoke. So just will not go in the detail. Similarly, these are the MOSA 4 and 6 where we can see the increase is very high. Similarly, in the resistive current also increase is very high. So here we can see the MOSA 1, 2, 3, and 5. There is no much increased trend we observe. So that's why we declared that these four MOSAs, that is MOSA 1, 2, 3, and 5 are the healthy MOSAs. Whereas the for MOSA 4, the amplitude of measured total leakage current increased from 600 microampere to 834 microampere after 1 year. And then again it was increased to 1059 microampere. So since there is a large increment observed in the resistive current, it was suggested to repeat the measurement after 3 months. And then when we measured after 3 months, there was no increasing trend observed after 3 months of the measurement. Hence, it was advised to clean the MOSA and keep the MOSA in service and observe the resistive current trend after 1 year. Because this leakage current may also part of the external contamination also. So if there is a surface is externally contaminated, then also the leakage current may little bit high. So this is the one finding. Similarly, on the MOSA 6, whatever findings we have seen, that after 1 year, the amplitude of the total leakage current was increased, that from 900 to 969. And similarly, the resistive current also increased from 88 microampere to 168 microampere. So since there is a continuous increased trend observed in the resistive leakage current, it was advised to replace the surge arresters because continuous 2 years the increasing trend was observed. So that is the advisable, that otherwise it may blast during the over voltage condition. These are the comparison which we have given, that MOSA 4 and MOSA 6. So the total leakage current, as we have discussed, that 600 to 1059, and for MOSA 6 it was increased from 878 to 969.4 microampere. Similarly, the resistive leakage current was increased from 69 to 135 and 63 to 168. So by comparing the trend analysis, we can decide whether the lightning arrestor should be replaced or it has to be, or should we continue in this service. This is the second case study which we have shown about the 132 kV surge arrestor. Here also 6 surge arresters were studied and analyzed the results for the continuous 2 years, that is 2023 to 25. And here we can see the MOSA 4 and MOSA 5. The increasing trend we observed, that is from 333 microampere to increase up to nearly 500 microampere. Similarly, the MOSA 5, that is 300 microampere to 465 microampere, total leakage current was increased. In resistive leakage current, if we see, that was the from 40 ampere to 40 microampere to increase up to 123. That means 3 times it was increased. And MOSA 6 or MOSA 5, the resistive leakage current is 69 or 59.6 microampere and it increased to 138. So 2.5 times it is increased. So these are the graph, and these are the graph for the resistive leakage current and the total leakage current for MOSA 4 and MOSA 5. So here our conclusion is there is no variation found in MOSA 1, 2, 3 and 6. So we declare that MOSA 1, 2, 3 and 6 are the healthy. So let it be remain in service. But MOSA 4, the amplitude of measured total leakage current increased from 333 to 465. Similarly, the resistive leakage current also increased from 40 microampere to 65 microampere. Immediately after 1 year also it was shown the increasing trend. So there was, once again we asked them to measure the leakage current and there was no increasing trend observed after 3 months measurement. Hence it was advised to clean the MOSA and keep the MOSA in the service and observe the resistive current trend after 1 year. For the MOSA 5, if we talk about, here also the increasing trend we observe. Then the measured total leakage current after 3 months we found was 765 microampere to 765 microampere, and the resistive leakage current was 178. So again, since there is a continuous increased trend observed in the resistive leakage current, it was advised to replace the MOSA 5. So like this, we'll have to do the analysis of the leakage current. We'll have to see not only the total leakage current, but we'll have to check the both the leakage current is current, like resistive leakage current and total leakage current. And based on that, we can decide whether the surge arresters are healthy or not healthy. If we have doubt, we'll have to repeat the measurement also after certain times, or otherwise maybe in the near future, we'll have to repeat the measurement. And based on that, we can find out or we can verify the healthiness of the surge arrestor. So conclusion is like that, measurement of total leakage current, that is IT, and measurement of the resistive leakage current, that is the IR, which is derived from the third harmonic resistive component. It has to be very important parameter to decide the healthiness of the surge arrestor. And increased trend in the resistive leakage current indicates the degradation of the MOSA. So if we do not take the timely action on the degraded MOSA, it may convert into the fatal accident or otherwise the system failure. So for the system reliability, we need to monitor the healthiness of the MOSA at equal time interval, and frequency may be decided 1 year or 6 months based on the trend analysis. So by adopting the balanced approach for the measurement frequency with the trend analysis, will result in the effective monitoring of the MOSA. So that's all about the two case studies of 132 kV and 220 kV surge arrestor, which is derived based on the trend analysis for the condition monitoring of the surge arrestor. So that's all from my side. If any question, I am available.
Thank you for the
No,
presentation.
I
Sir,
don't
do you
have.
have a question?
I don't have any question.
Okay, sir. So next we have Venla the paper title Explainable Genomic AI for Predicting Diabetic Mellitus. Venla are you there? So next we have Bo- Bogavarappu, paper titled God Forge, a hybrid multi-agent framework for execution-driven workflow automation in Visual Studio Code.
Yes, I'll present the PPT. Me and my two classmates are there with me, so we three will present accordingly. Oh, 1 minute. Sir, is my screen visible?
Yeah, it's visible,
Yes.
Kunal.
Yeah. Yeah, my first
Good
teammate.
afternoon.
We continue.
Yeah. So, good afternoon, respected chairs, professors, and fellow researchers. Today, we are presenting a paper titled GodForge, a hybrid multi-agent framework for execution-driven workflow automation in Visual Studio Code. I will begin by explaining the motivation and problem definition, after which my co-author Kunal will cover the system architecture. Large language models have significantly transformed AI assisted coding. Tools such as GitHub Copilot have improved developers' productivity by providing intelligent code suggestions. However, these tools primarily operate in a suggestion only mode. They do not execute the everyday workflow actions that developers still perform manually. This leads to what we refer to as the execution gap, a disconnect between AI agent suggestions and real world executed action. The gap results in increased context switching, higher cognitive load, and a greater likelihood of errors, particularly during repetitive and maintenance oriented workflows. This motivates the research gaps we identify. Next slide, please, Kunal. Based on a study of extensive AI developer tools and prior research, we identified five key major gaps. First, there is no clear distinctions between operations that require deterministic trust, such as file deletion, or Git operations, and tasks that allow creative generation, such as README writing. Second, existing systems lack a cross domain undo system. File edits, Git actions, and documentation updates are handled independently. There is also a lack of structured button based automation integrated directly into the IDLE. Mainly, systems rely heavily on LLMs, leading to speed, cost, and reliability issues. Finally, there's no particular framework that balances automation and accountability and developers' trust also. Based on these gaps, we identify our problem statement. The objective of this work is to develop a hybrid multi-agent workflow framework for Visual Studio Code that addresses these limitations. It balances deterministic reliability for structural tasks with selective use of LLMs for contextual generation. It ensures complete reversibility of all automated actions through undo mechanisms. It maintains developers' trust through explicit UI triggers and transparent login. And finally, it integrates natively into the IDE without introducing additional context switching or cognitive overhead. Overall, the goal is to bridge the execution gap between AI suggestion and accountability action in software development workflow. I'll now briefly introduce the system architecture, which is the three agent architecture. Godforge is built using a modular multi agent architecture consisting of three independent agents. The file and folder agent performs file creation, deletion, renaming, movement, and edit using fully deterministic logic. The GitHub agent manages branch creation, commits, and pushes using the GitHub REST API without relying completely on the local Git CLI. The doc agent handles readme generation and updates and is the only agent that uses an LLM. Importantly, these agents operate independently and do not communicate with each other, ensuring safety, clarity, and accountability. With this overview of the architecture, I'll now hand over to my co-author Kunal, who will be explaining the technical designs and safety mechanism in more detail.
Yeah. Yeah. Good afternoon, everyone. My name is Kunal, and I'm going to continue what Seema explained. Uh, the hybrid execution model, as Seema mentioned before, we our main motto is to not include the LLM as far as possible. So we came to the logic like we made two agents called a file manager and another is GitHub agent. In those two agents, we didn't involve an LLM. If in future, if the LLM existence is become more, we can add it like a backup thing if the logic fails. So the only LLM we used is in README generation. Like nowadays, so many students and developers perform their projects and they are most difficult and they didn't get any GitHub scores or else any project scores very much higher and also less project scores where they are evaluated by the companies. So for those projects, those need to be showcased very nicely. Further, the README markdown is very important to showcase. So for that, we are using an LLM. As for now, we are decided using Olama, a local platform where we can use local LLMs by downloading the models. While deployment, we could use any API resources or we can use a fine-tuned deployed model. And the architecture follows like for front end, we are going to do with React or Next.js in Studio Code extension making. And for backend, we plan to make using Flask or also we can go with Fast API. Based on this, we are using GitHub API and also for doc generation we are using an LLM API and for file and folder we will use the already defined module inside the VS Code itself. And coming to the file folder architecture, the main responsibility of this is managing whole file and folder management. Means we can create a file, we can delete a file, we can rename, we can move, and we can even edit the lines. Like if the user types or if the user selects removing a particular lines or editing a particular lines like within a range call remove lines from line 20 to line 45 without entering to the file, it automatically automates the thing and we could do. And there is one thing which uniques this project is the safety management. We introduce the rollback system where the VS Code itself stores some file history inside it, and using that history snapshots, we can get back the previous versions of file which we deleted or edited. So this is the main thing which we did, and no LLM is involved in it. And next, coming to our GitHub agent architecture, in this we are using GitHub REST API. Means we can bring from GitHub token. Uh, GitHub API. From that GitHub API, we make GitHub calls. We research some of the things like does it cross any rate limits. So there is no issue. Like for 10 minutes, we can give 5,000 requests. So it's not a matter of 5,000 requests crossing because within the 10 minutes, no more than 100 people or 200 people cannot give 5,000 requests at a time. And another main thing is branch creation. We can even create the branch inside the from the extension itself, and we can also undo the GitHub reverts. Like we introduce the system with GitHub API and reverting. Uh, we can even go to the fifth latest commit, like 10th latest commit also we can go, so that user cannot lose their previous versions. And next one is docgen agent architecture. This is the final agent which we are going to do, and it is mainly for generating the readme. We will use an LLM, like we are as per now we planned using Alama or Mistral because they are free of cost. In future, if there is free or a low cost like Claude or GPT models, we could go with it. And this is the readme generation, and we can even for this readme generation also we can get a previous versions by reverting back using the VS Code app itself. And next I am handovering it to Param Mohan Kolab. My turn.
Yeah, hello all. I'm Param. Uh, yeah, carrying on. This is a brief workflow of what our framework would look like. We would have a user interface where the user can choose to work with any one agent and their operations. These are clearly defined, so there's no confusion. Yeah, and then moving on to the safety mechanism. Safety mechanism, we are implementing a snapshot based redo system or revert system. So basically, every change you make, there'll be a saved copy in the backup. So every time you wish to undo a change or there's a mistake that happened, you can always go back to it. It's similar to the revert function in Git, and but we are implementing this across all agents. Kunal, next. Yeah. So as we mentioned, this is a multi-agent implementation. Basically, these individual agents do exist, but they have their own limitations. While most of them are very LLM heavy, API based heavy applications, we aim to make it hybrid in the sense that we use deterministic functions as well as use LLMs for the creative aspects of it, like the README generation. So as you can see, most of these individual agents don't feature a rollback or a undo feature. Yeah, next. So uh, with this, as we are automating developer operations that they do daily, we aim to speed up this process, automate this process, which will result in higher employee efficiency. Newer developers, junior developers will have an easier time dealing with commands like git commands or file operations that they're new to. So, yeah, with the safety feature, we also ensure there's always a safety net to always undo the errors and rework on it. This way, we ensure smooth operation of development in software. Yes, next.
You have 1 minute to conclude your presentation.
Yes, sir. Yes, sir. Yes, sir. So to conclude, this paper features a multi-model framework that aims to automate all developer necessities with the cost saving in mind, as well as a safety net in case of large language model hallucinations or faults. Yes, sir. That will be a conclusion. We are open to any questions if you have any, sir.
Thank you for the presentation. Sir, do you have any
Yeah.
question?
Yeah. What are the loopholes for this project? You haven't given any drawbacks of your project. Any loopholes or drawbacks?
So till now we plan to make this. One loophole we find was like those LLM deployment things, sir. Like as per now, as I mentioned, we are using Olama local model, but for deploying we want to use some open router or ChatGPT APIs. But using those will cross the rate limits. So that thing we are going to plan like we are planning to make a fine-tuned model, or else we are planning the users to make the Olama installed in their systems.
Okay, you have given here the design phase only, right?
Yes, sir.
Okay, fine. Thank you.
Yes. Any more doubts, sir?
No, thank you.
Yeah. Thank you.
Thank you, sir. Thank you.
So next we have Navidita, paper titled Online Recruitment Fraud Detection. Navidita, are you there?
Yes, sir.
You may please begin with your presentation.
Yes, sir. Good afternoon, everyone. Our project title is Online Recruitment Fraud Detection Using Deep Learning Approaches, where the paper ID is 11995. The main agenda of this project paper is abstract, introduction, literature review, problem statement, objective, proposed method, experience setup and result, conclusion, and references. First, we will discuss about the abstract. The abstract explains the fake job postings are becoming more common on online recruitment platforms, creating risk for job seekers. To address these problems, the study uses deep learning techniques to detect fraudulent job advertisement. A public fake job posting dataset is used to train and test the models, ensuring reliable evaluations. The proposed approach, the combined GPT-2 and also ExcelNet and also LSTM models to better understand job descriptions, content, context, and sequential patterns. By integrating these models, the system improves the fraudulent detection accuracy and helps to protect job seekers from online recruitment scams. Coming to introduction, the online portals have become widely used because they make job searching fast and convenient. However, the growth of online recruitment has also led to a significant increase in fake and fraudulent job postings. These fraudulent jobs can also cause the financial loss, identity thefts, and personal loss to job seekers. The traditional fraud detection methods often fail to identify complex and evaluation scam patterns, making them less effective. Therefore, we can also advance in the deep learning models if necessary for more accuracy. Coming to the literature review table, we use the authors with Saumya Pokhar with the dataset LinkedIn profile data, and also with another author Monica, where labeled dataset they have used. Coming to the problem statements, where the online recruitment platform are increasingly affected by the fraudulent job postings, where the affected by the fraudulent job posting which misleads the job seekers and result in financial loss, identity thefts. Also, they can reduce the trust, and also online job portals. Existing fraudulent detection methods struggles to identify the complex and evaluate scam patterns, making them less effective. As a result, the strong need to for system that provides higher accuracy and also better security and also increase the trust in the job seekers. Coming to the objectives, where we use the advanced deep learning techniques, the system combines GPT-2, ExcelNet, and LSTM models to accurately identify whether a job listing is real or fake. By capturing the context, meaning, and the sequential pattern present in job descriptions, the model can better recognize the scam related to language and also the structure. The overall goal is to improve the trust and ensure the safety for job seekers on online recruitment platforms. The flowchart detailed about the input job postings, text pre-processing, context and semantic extraction, sequential pattern learning, fraud classification, and performance metrics. Where they collect the text in, then pre-processed by cleaning and preparing it by analyzing. Next, we go for context and semantic extraction, where it uses the GPT-2 and ExcelNet, which helps the system understand the meaning of job descriptions and identify the hidden fraudulent related language patterns. After this LSTM, this is applied the learn the sequential pattern and behaviors commonly found in the fraudulent job postings. The output of these models are combined to classify each job as genuine or fraudulent. Finally, it will classify based on the accuracy, precision, recall, and F1 score. The validate the effectiveness and reliability of the proposed fraudulent detection approach. These are the experimental setup using parameter symbols, exact value unit, and description, where the data size is 17,880, where the total number of job posting used in this experiment. The training data, where the exact count is 80% and testing we use 20%. This approach are number of training iteration over the data sets. Coming to the confusion matrix, where the fake job posting predict dataset with 17,880 records was used for this experimental. Data was split into 80% of training and 20% of testing. after pre-processing. A hybrid deep learning model using GPT-2net, XLNet, and also LSTM was trained for 10 epochs. Model performance was evaluated using accuracy, precision, and F1 score. These are the epochs where the loss in the epoch of each iterations, where the accuracy increased by 85.8%. Coming to the conclusion part, where the employment of the fraud detection plays a vital role in the protection job seekers by ensuring they receive only genuine job offers. Multiple machine learning classifiers were analyzed to identify fraudulent job posting using a supervised learning approaches. Among all these models tested, the random forest classifier achieved the best performance, demonstrated strong capability in detecting job scams. The proposed methods achieve a high accuracy of 98.2%, with significant outperformance existing approaches and providing the effectiveness in the improving the reliability and safety of the online recruitment platforms. These are the reference papers.
Thank you for your presentation. Sir, do you have any question?
Ma'am, you have used a random forest classifier where the accuracy is shown as 98.27, right? So
Yes,
any
sir.
other method you have compared with it?
Yes, sir. GPT-2, XLNet, and
GPT-2 and
LSTM.
XLNet.
Yes, sir.
Okay, what is the accuracy for that?
So 85.8%, sir.
And what is the size of your data set, ma'am?
So 18,850.
18,000 or 17,880?
17,850, sir. Sorry.
17,850. Okay, okay. Thank you, ma'am.
Thank you, sir.
So next we have Rebecca, paper title, Skills and AI-based career mapping and market trend analysis.
Hello, sir. Is my video visible?
Yes, you may please begin with your presentation.
Okay. So, good afternoon, everyone. I am Rebecca Russell, and today I'll be presenting our research title, Skill Sync AI-based career mapping and market trend analysis. So, the core idea of this research is to address the growing disconnect between the individual skill set and rapidly evolving industry experiments using AI and market intelligence. So, the agenda of today's presentation, I'll be begin by discussing the problem statement and research motivation, followed by the objective and a brief literature review. Then I'll explain the proposed framework, methodology, and highlight how market trend is integrated and discuss the related applications and overall impact. And then I'll conclude with the future research directions. So the career guidance system today are largely static and generic. So they often fail to adapt to the fast changing nature of the industry, skill requirements, especially in emerging technology domains such as the AI, data science, and cloud computing. So this result in a major mismatch between what individuals know and what the market actually demands. So our focus, the study focus on addressing this gap by developing an AI-driven framework that dynamically maps individual skills to the suitable career paths while incorporating real market trends. So the key research questions we address is how can an AI-based systems dynamically align individual skill profiles with the evolving market trends to deliver personalized and future-ready career recommendations. So the motivation behind this work stems from multiple real-world challenges. There is a rapidly growing skill gap in emerging technology domains. So the upskilling today needs to be continuous and adaptive, not on like one time. So the existing career guidance tools lack the intelligence and personalization. There is a strong need to align individuals not just with the current roles, but with future ready career paths. So these factors collectively motivated the development of the skill sync. The primary objective of this research is fourfolded. First, to develop an AI-based dynamic career mapping framework. Second, to integrate market trend forecasting directly into the recommendation process. Third, to construct a personalized skill DNA that captures an individual's strength and the gaps. And finally, to generate adaptive and a gamified upskilling pathway that evolve with both the user and the market. So, existing career guidance systems are largely rule based or like questionnaire driven. So, some systems apply collaborative or content based filtering technique. However, most related work show key limitations. So, there is limited incorporation of the real time labor market data. Semantic understanding of skills and job roles is often shallow. Additionally, most systems lack adaptability to changing the user profiles and evolving market trends. These gaps clearly indicate the need for a more intelligent and a dynamic approach. So this slide shows the proposed system framework for the skill sync. The flow begins with the user input, which is sent through an API and stored in the database. A recommendation request then triggers the machine learning processing layer. After analysis, the backend generates a structured response, which is finally displayed to the user as personalized career recommendations. So this framework provides a clear end-to-end pipeline from data acquisition to the intelligent decision support. So our methodology follows a structured AI-driven pipeline. First, we collect the user skill and interest data and perform pre-processing to ensure the data consistency. Next, we'll feature engineer. Feature engineering is applied to construct a personalized skill DNA. We use the sentence bird to generate transformer-based semantic embeddings, which are then combined with the categorical and numerical attributes in a single unified skill DNA vector and is stored in the database. For career matching, a hybrid approach is used. Content-based matching is performed using the TF-IDF with cosine similarity, while semantic matching is achieved using the SBIRD and SBIRD embeddings indexed with the FAIRS for efficient retrieval. Rule-based filters further refine the recommendations. A dynamic career map is then constructed using the knowledge graph representation, and reinforcement learning is applied to model the adaptive upskilling progression path. So a market trend analysis is then integrated through skill demand extraction using the heuristic processing and named entity recognition, followed by temporal forecasting with LSTM models. Finally, clustering and cohort analysis support the personalization, explainability modules provide transparent reasoning, and the system is then evaluated and deployed with the front end. So to ensure future readiness, market trend analysis is integrated into the system. We extract the skill demand indicators from the market data. Temporal trend forecasting is performed using the LSTM models. Career recommendations are dynamically weighted based on demand trends. This allows the alignment with emerging and high demand roles rather than just static career paths. So this UI here shows our implementation. So this is actually our project's UI. So the result demonstrates significant improvements. The recommendation relevance is enhanced through semantic matching. Skill gaps are identified and more effectively. Most importantly, the system dynamically adapts to changing market trends, making recommendation more future oriented. So for applications and impact, the SkillSync has wide-ranging applications from the students to the policymakers. For students and graduates, it supports informed career decision making. Educational institutions can use the insight for the curriculum alignment and incorporate the HR teams. The corporate HR teams can leverage it for workforce upskilling. Policymakers can gain the valuable insight into the demand skill trends at a macro level. So to conclude, SkillSync enables dynamic AI-driven career mapping. The SkillSync DNA concept allows a depersonalization. Market trend integration ensures future readiness, And overall, the system bridges the gap between the individual capabilities and the industry demands. So the future work includes integrating the live job portal APIs, expanding the knowledge graph, and implementing full reinforcement learning, and adding conversational AI for interactive career counseling. So thank you for your time and attention, and I'll be happy to take any questions.
Thank you for presentation. Sir, do you have any question?
No, I don't have any question.
Okay.
Thank you.
So next we have Rehan, paper titled SVAF, a modular framework for comprehensive smartwatch vulnerability assessment.
Yeah, hi. I hope my screen is present. Is it visible?
Yes, it is.
No. Okay. Good afternoon, everyone. So my research topic is about Smartwatch Vulnerability Assessment Framework. Short form is SWAF. It's a modular framework for comprehensive smartwatch vulnerability assessment. I'm currently doing my PhD from GLS University, under which I'm presenting this paper. So, what is basically the motivation and background behind this research is that nowadays, if you look around, smartwatches and fitness bands are now integral personal IoT devices that everybody carries and everybody keeps with them for mainly timekeeping, fitness tracking, notifications, authentication, health diagnostic, and for some cases also payments also. So, they are continuously connected to your smartwatch. They are continuously a cloud service that is being used. There are other IoT devices also, and that creates a large persistent attack surface that was previously unexplored. And if you look at it right now, the resource constraint is there when you talk about a watch which is really compact. So it creates a limitation where the traditional security solutions are not really applicable on it at all. So for that reason, we require some kind of focused research towards the smartwatch security, and that is exactly where this framework sits. Now, what is exactly the problem statement here? There are a lot of IoT security tools that exist in the market right now that provides the vulnerability scanning for IoT devices, but there is a small problem. Either they ignore the smartwatch altogether, or they treat them as generic Bluetooth or IoT device, which would not give you a specific tailored smartwatch related analysis. So, what are the things that we require? We require permission based analysis of the application with which the smartwatch is connecting. We need to look into the pairing mechanism also. We need to look into the firmware of the smartwatch also. So for that, we require something that can do that in a single platform. So that is the research gap that this particular framework is trying to address, where we don't really have any modular tool right now in the market that does BLE analysis, firmware analysis, CVE based analysis, application auditing, exploit simulation, firmware analysis for an entire smartwatch workflow. So that is what SWAF is. So that is the aim with this entire framework, that I need to provide a smartwatch specific vulnerability assessment framework that can be modular so that anybody can add on new tools as the technology progresses. It can be practical for anybody to adopt, be it a researcher, be it the manufacturer, be it the students who want to learn upon it. So that is exactly what the workflow I have designed for it. I have implemented some of the features, and mainly I have made it both CLI and GUI both. So whoever that is accustomed with CLI, they can use CLI. Whoever that is accustomed with GUI, they can use GUI. So yeah, if I talk about the existing market that is that we have before this particular tool that would be going public, we have generic IoT security framework that exists but are not smartwatch specific. We have a lot of smart home and consumer IoT security analysis that shows us that systematic weaknesses are there in these existing devices. We have mobile application security tools like, let's say, for example, MobeSF, or you can talk about any antivirus tool that you would put in your phone, but they are not really looking into the permissions and behavior with this smartwatch and app connected to each other. So that is where the limitation lies. We don't have any analysis tool that could tell us what that smartwatch firmware exactly has. So that is where this kind of tool comes into the play. So if I show the architecture of the SWAF, so basically what I have done here, I have created is this reusability and interoperability related smartwatch framework that would give you a modular support which has multi-layer analysis also. So I'm not only going to look into the BLE or just the application, we are going to mainly cover three components: Bluetooth, application, and the watch itself, the firmware. And it would be both based on CLI and GUI. So this is how exactly the interface looks like. So for the primary, based on the front end, for every user, you are having either GUI or CLI, based on which the user would be able to interact with the application. In the backend, I have a controller that could assign the task based on whatever requirement user is providing. So it can be Bluetooth scan, it can be get info extraction, it can be recon, it can be man in the middle attack, it can be firmware extraction, it can be CV based lookup, it can be app permission audit, it can be exploit automation, it can be fuzzing. Whatever it might be, the controller would look into it, and at the end you can carry out multiple of these attacks, and based on that it would give you an HTML report that you can then either submit to the manufacturer or whatever your requirement was. So you will be able to create a tailored report based on whatever module that you have selected. So if you have done only BLE scan and then only BLE MITM, you can get the HTML report for just those two things. And module wise, if I have to give you an understanding what all this feature is all about, so BLE scan is basic BLE advertisement beacon capturer. What it will do, it would just start scanning for any nearby devices that has BLE enabled. Then it would identify which of those devices are smartwatches, and it would give you a drop down list of all those smartwatches that you can select from. Then you can do get info extraction. Get basically means general attributes. That is the way basically smartwatch and smartphone exchange information amongst themselves. So you would be able to dump all that services and characteristics from get profile, and based on that you might be able to identify a lot of sensitive services also. Then you have BLE recon, where you would be able to identify and fingerprint the entire BLE stack, addressing, advertising patterns, protocol behavior, to identify if there is any vulnerabilities lying in that layer or not. Then you have the MITM layer, where basically we would be able to have two kind of simulations. One is live MITM, where your laptop would be trying to connect to the smartwatch while the tool would be trying to do man in the middle attack in that live communication. Or what you can do, you can carry out the connection of your laptop with the smartwatch, and through Wireshark or some other tool, you can capture the pickup file of that Bluetooth communication. You give that pickup file to the tool, and then based on that pickup file, the tool would be able to identify if there was any possibility of MITM in there or not. Then there is a firmware extraction and analysis, where what you can do, you can provide the firmware files if you have with you to this tool, and the tool would be able to analyze the firmware to find out if there are any weaknesses, any vulnerabilities in that particular firmware or not. Then if I talk about the exploitation and analysis part, we have a CV based lookup also, where let's say like during your analysis you found some vulnerabilities and you want to identify if this is a known vulnerability or if this is a new vulnerability. So there would be a backend database that can be connected. You would require internet connection for it obviously, but based on that you would be able to create a link between an existing vulnerability and the vulnerability that you have identified. I have also added an option where instead of connecting internet for the NVD or any kind of national vulnerability database, you can create your own custom databases of vulnerabilities within your organization and look into that while you are doing CVE lookup. Apart from that, you can provide the APK or the application of that particular watch that your phone is connected with. You provide that application, and the tool would be able to do the analysis of permissions for that tool, and that give you the answer for it. So what I have done, I have done the implementation based on Python, and control layers and everything is designed through that only using various libraries. And I have created some of the practical analysis also using some watches, and I would give you the table for that. So I have taken mainly 4 watches for this particular research paper. I have done the analysis of other watches also, where I have taken Goki, Honor, MI, and a generic Chinese smartwatch that you could find from Amazon for very cheap prices. The BLE scan and the BLE recon, I was able to do on every single one of these devices. MITM was feasible on Goki. The Honor Band uses encrypted pairing prevention, so I was not able to do MITM on that. Same goes for Mi Band 4, and generic I was able to do because it does not have any BLE authentication at all. Then if you talk about simulation, the PKF relay functionality worked on Goki, but it did not work on Honor or MI because of the encryption, but it worked flawlessly on Chinese generic smartwatch. Firmware extraction I was able to do for all the firmwares that were publicly available, but Honor and Me does not provide that, nor does they provide to capture the firmware while it is being uploaded from the application to the watch. So that was not possible. CV lookup works on every version based on whatever info that you have found earlier. If I talk about permissions, all the applications had multiple permissions that could be very questionable. Apart from that, if you talk about the exploit relay, the get overflow simulation worked flawlessly. the honor band and MI also with some limitation, I was still able to do it, and generic smartwatch I was able to flawlessly go ahead with it. If I talk about fuzzing, I was able to taste it on the Goki, honor band, me, and generic, but the Mi Band and the Honor device started irresponsing or started restarting after the fuzzing. But after the generic smartwatch was fuzzed for 2 times, it froze completely and never came back to life. So that is the experience that I have with my experimentation from my tool. Now, what are the key observations here? So observation one is BLE assessment is the strength of this particular tool. Apart from that, the security posture difference provides us that like the reputed companies like Honor Band and MI are providing much better security solutions, but the generic smartwatches that are being pushed to the market every other month are not having that kind of security with us. Apart from that, the budget variable range that is the most common in India right now is the most risky out of them all, that 1000 to 3000 kind of range, where you would find the most amount of generic smartwatches that has this kind of vulnerability incorporated with it. And based on that, I can tell the statistics for my tool.
You have 1 minute to conclude your
Yeah,
presentation.
sure. So based on these statistics, the BLE scan took place in less than 8 seconds, and the statistics are in front of you. Around 1 minute or so, it would take for you to go through all the modules that are present. If you want to manually do it as and when you require, it would take few seconds for each of the modules. Now, there are three limitations primarily. If the OTA is encrypted, the firmware is encrypted, we would not be able to do it. The MITM is dependent on the security that has been implemented by it, and full automation and scoring is difficult because smartwatch security posture doesn't really exist in the market. So those are the three limitations. And if I have to conclude, so smartwatch and fitness bands are they do handle highly sensitive personal information, and they are deeply integrated into the daily life. So specific tool like this is highly required for this market right now, and this is a tailor-made modular tool that you can just take upon, and if you want to add any additional feature, you can do that also. So it would make a really easy solution for somebody who is doing research, or it can be a really easy solution for the manufacturer also. But keep in mind, smartwatch vulnerability assessment framework is not a hacking tool, it's an assessment tool. So yeah, these are all the references that I have taken. Thank you, anyone. If you guys have any questions, I will be happy to answer.
No, it was
Thank
a
you.
good presentation. I like it. Thank you. I
Thank
don't
you.
have any question.
Thank you for the presentation. So next we have Ok Srinivasulu. Paper title Synerging Framework and Genetics, a novel paper minimization technique for MIMO OFDM. Srinivasulu, please turn on the mic.
Sir, good afternoon, sir. Am I
Good
audible?
afternoon. Yes, you may please begin with your presentation.
Yes, sir, sir. Let me share the PPT. Sir, is it visible?
Yes, it is.
Yes, sir, yes. Actually, sorry for troubling you. I am in journey. It may interrupt in middle. Please excuse me. Yes, sir. My topic is synergizing. Means my paper title, Fireworks and Genetics, a novel PAPA peak to average power ratio minimization technique for MIMO OFDM. Myself, Srinivasu, research scholar, under the guidance of Professor P. Rajesh Kumar. He is the co-author, Andhra University, Vizag. Coming to the contents. So, abstract objective proposal method, flow diagram of FWG algorithm, PAPR analysis, causes of PAPR, simulation results, conclusion, future scope, references. Coming to the abstract, actually my system is the MIMO OFDM system. Nowadays, MIMO OFDM system is a key technology for communication, all broadband wireless communication systems. But it is facing the problem of peak to average power ratio. To avoid this, yes, I adopted the optimization technique. That is the FWG, firework-based genetic optimization algorithm procedure to reduce the PAPR. Generally, this FWGO is applied to the GPTR PTS. GPTR PTS stands for the Gaussian Pulse Tone Reservation Partial Transmit Scheme. So when we apply the actually in GPTR PTS, so peaks will be reduced, but average power will be increases. So that is why I am adding I implemented the FWGO to GPTR PTS to reduce the average power. Thereby, it will increase the spectrum efficiency and energy efficiency. So coming to the MIMO OFDM with PAPR reduction. So objective or problem statement is so to lower the PAPR in MIMO OFDM systems. MIMO OFDM systems. It will be implemented by using the MATLAB. So coming to the block diagram, the fireworks, genetic optimization, cross sample, stone reservation, pulse transmission scheme technique, block diagram is like this. So we can give the serial data to the serial to parallel converter. It will convert the serial data into parallel. Then it will be given to the IFFT. So means the inverse fast Fourier transform, which will convert the frequency domain signal into the time domain signal. Then it will be given to the peak power optimization using FWGO GPTR PTS. So means it will observe the peaks, means the page rotations. Mainly it will observe the page rotations like that. So up to the B1 to PV, and it will produce the lower average PAPR. Oh. So means the whatever I used here, the FWGO, these are the steps involved in this. Initially, the algorithm by defining all essential input parameters, including the stopping criteria, page-related variables, and other control parameters. Second step is so choose n places for fireworks at random. Then it will be computed the fitness of each PAPR seed. If the predefined stopping condition is not yet fulfilled, continue the iterative process. So denote n fireworks around the current position based on the defined exposition model. So for each firework, so like this, it will continue the steps. Oh, these are the steps in. This is the mathematical expression for the PAPR we're going to analyze. So mainly these are the reasons for the PAPR in MIMO OFDM. So when we are using the multiple antennas and also multiple antennas in MIMO and the subcarriers for each signal for the subcarriers. So use of multiple antennas, combination of multiple subcarriers, non-linearities in the power amplifier, phase rotations, intercarrier interference. These are the main reasons for PAPR in MIMO OFDM system. Coming to the simulation results, these are my simulation parameters for the FWGO G50R PTS. So, the VPR performance evaluation. So, PPR on y-axis and the SNR on x-axis signal to noise ratio. These are the various techniques. SLM PTS means the and also CFIM MIMO FSO. So comparing with the existing techniques, so here we are observing how are the proposed system MIMO FWS GPTR is producing the lowering the PAPR. This is the 3.7. Like that for 8 into 8, 16 into 16 also simulated. So the simulation results are like this, BER performance. So for 1666.2, sorry, for 18 to 8, it is the 5. Now coming to the PAPR performance, it is the graph of PAPR on x-axis and the CCDF, cumulative CCDF on y-axis. These are also executed for the 4 into 4, 8 into 8, and 16 into 16. Here we observe this is the 5.8. For 8 into 8, it is the 7 point something, and 16 into 16, 7.5. Here we are observing so when number of antennas are increasing, so how the PAPR is reducing. So these are in my conclusions, you see the BER. So whatever I showed previously, 4 into 4, 8 into 8, 16. So 3.7 dB at 10 power minus 6, and while 10 power 10 power minus 6, 8 into 8, like this. And also PAPR results are here, which is less compared to the existing methods. Coming to the future scope, this work will be extended with memo epidemic equalizations, which plays a significant part in communication systems. So by using the various equalization methods, MLE zero forcing, W selective zero forcing, further BER will be reduces. And also ISI, ICA, general communication problems also reduces. These are references. Thank you, sir.
Thank you for your presentation. Sir, do
Sir.
you have any question?
No, I have no question.
Hello, sir. Any queries, please?
So next we have Ronak, paper titled Toward Energy Aware Auto Scaling and ERP Based Framework for Kubernetes Microservice.
Good afternoon, everyone. Am I audible?
Yes.
Sir, actually, I am unable to hear, sir. I am in journey.
Yes.
Yeah, just a minute. Yeah, is my screen visible?
Yes, yes. Thank you, sir. Thank you for
Yes.
patience.
Okay. Good afternoon, everyone. Myself, Ronak Bagaria. My co-authors are Rachna, Dhanush, and Professor Prafulata. We are from the Department of Computer Science and Engineering at PS University, Bangalore. Our work is a framework for Kubernetes microservices. So let's understand what autoscaling is. Autoscaling is the dynamic allocation and adjustment of resources to handle changing workloads. And this is very critical for performance of many modern applications that we use in our day-to-day lives. So the way Kubernetes does it out of the box is it uses three primary ways to do it. One is horizontal pod autoscaler, then vertical pod autoscaler, and cluster autoscaler. So horizontal pod autoscaler is when you scale the number of pods itself, that is, you add more replicas to an existing pod to handle increased workloads. Vertical pod autoscaler is when you adjust the limits of existing replicas of pods to so that they can handle workloads accordingly. And cluster autoscaling is when you add or remove nodes to the Kubernetes cluster itself. So you have more instances of a node handling these requests. So that's how Kubernetes does it out of the box. Now, the problem with this approach is that Kubernetes uses only CPU and memory metrics to make these scaling decisions. So whether you are scaling out or whether you are scaling in, all of that decision happens only based on the current CPU usage and the current memory usage. And energy is a very critical metric in modern workload heavy applications because, as you can see, there's lots of AI data centers coming up, and the amount of energy they require becomes very critical for measuring and then scaling based on the workloads. So, that is the gap that we aim to address. So, as I mentioned earlier, HPA uses the current CPU and memory usage. So, for example, say for a particular service, if 60 or 70% CPU is being used, and the predefined threshold was say 40 or 50%, then HPA takes the decision and adds a replica so that the request can be handled gracefully. And scaling in again is when you remove that replica when the workload has dropped down so that you don't waste resources. Uh, the cap here is again, of course, there is no energy or power metric that comes into play in these decisions. So our proposed solution is to introduce energy as a first class metric to make these decisions. So the primary metric that we came up with and we tested is EPR, which is energy per request. So let's say that for your particular service, there are 10 requests and the complete power being used by that service is 5 joules. So the energy being used by a particular request would be 0.5 joules, and we would compare that against existing thresholds and baselines and then make our scaling decisions. Um, this is a system architecture which has three primary layers. The first one is the user layer, which is a client that interacts with any application through HTTP requests. Then we have the service layer, which is managed by Kubernetes and its various pods. And finally, the core part of our research, which is the monitoring and control stack, which comprises of three main components. The first one is Kepler. Kepler is an open source project. The full form is Kubernetes based power level exporter. So Kepler measures the entire power being used by the system or by that Kubernetes configuration and attributes the power to each pod or to each container based on the computational load being executed or the number of requests being executed. So through Kepler, we can get pod level or container level metrics. Since our framework is primarily based scaling is based on the pod and not on the entire system because different pods behave differently. So Kepler helps us make this distinction. And Prometheus is where the metrics are exposed. So Kepler sends these metrics to Prometheus, and then our custom autoscaler can query Prometheus to make any and all kinds of decisions. So the way companies like Intel or AMD do this is they have their own hardware counters to measure the energy being used by each pod or each hypervisor instance. But those are closed source and those are proprietary, so we can't use that for any kind of custom research. That's why we went with this open source application. Uh, yes, so this is our system architecture. The custom autoscaler is implemented in Python, which executes shell scripts that run the Kubernetes kubectl APIs. Yeah, so this is our implementation. The first thing that we do is we define some static thresholds for three kinds of workloads. So we conducted a research on three types of workloads, which are constant burst workloads as well as CPU intensive, highly computationally intensive workloads. Uh, so for example, here I've set the upper threshold to 8 joules for constant and 12 joules for burst. These are configurable, obviously, and these change depending on the workload being deployed. And as the autoscaling happens in real time while the requests are being serviced, the thresholds can dynamically adapt. So the essential idea is to not scale unless performance is significantly worse than observed otherwise, because scaling itself has an overhead of energy, right? When you scale more or you scale down, there's an overhead which can add to latency as well as lead to more energy consumption. So we scale only when there is worse performance. The second thing is we calculate the trend of EPR being affected by each request. So we take the most recent EPR and the oldest EPR and we calculate it over a window and we see what the trend is, whether it's improving or whether it's degrading, and then we take a decision accordingly. Uh, the third one is a cumulative energy score, which is a weighted sum of EPR scores, the efficiency, utilization, and resource penalty. So EPR score gets the most weightage here because we, in our research paper, we take this as the primary metric. And efficiency utilization is the utilization of a particular replica. Resource penalty is applied on any service that has a lot of replicas. So, for example, a service started with two replicas and we scaled it to say four or five replicas. It gets a resource penalty because you want the system to penalize more a service that's hogging up more resources. So this makes sure that there is no that the other services can also use other resources. And finally, our scaling triggers are based on all of these metrics. So we scale out or we add more replicas if the EPR is greater than the threshold or the trend is degrading, as well as the energy score is less than some predefined value. So for example, for our workload, we took 25. It could be anything depending on the workload. And scaling in also follows these metrics. So our experimental setup was a single node Minikube Kubernetes cluster that we hosted on Docker. And the system had 16 GB of RAM, of which 9 GB was allocated to Minikube, four CPU cores. Istio service mesh was used by the microservices to talk to each other. So we used something called New Bench, which is a open source microservice framework to run our microservices. We didn't write our microservices; we executed it on the New Bench. And Istio helps the services to talk to each other. Of course, we had Kepler, Prometheus, and Grafana to visualize all metrics. And our primary workload model that we tested for this research was Pi workload. So there are four services that we have. S naught is the orchestrator service, that is an Nginx gateway that routes all these requests to the other microservices. S1, S2, and S3 perform computation of pi. So pi has infinite number of digits, right? 3.14, and then there's lots of digits. So each service gets a particular request to compute the remain a certain number of digits of pi to the right of the decimal, and that adds computational load to the system. So all of these services computed to different degrees, and hence they mimic different kinds of workload that can be deployed. Uh, and these are the results that we obtained through our research. So we can see that there's a significant improvement in EPR in constant medium as well as CPU intensive workloads. But the framework didn't perform that well for bursty workloads because there is no predictable pattern to a bursty workload. You can have a spike in a request at any point of time. So that is where this framework didn't perform very well, but it performed really well for constant well and CPU intensive workloads. And this is the second table compares the replica counts for energy aware as well as the CPU HPA implementations. So from this research, what we gained was we understood that CPU HPA can sometimes either be too aggressive or too conservative in making any scaling decision, and that has an adverse impact on the energy being used. Even though it might look like the CPU or the memory is being conserved, but in the long term, for if you take per request metrics, then it ends up being a bad choice. Um, as you can see for constant medium workload, the green line represents the EPR for our custom framework. And you can see the EPR steadily decreases for this workload as compared to CPU HPA. And even though you can see a slight increase in power on the graph on the right, but that's because you're able to service more requests in the same amount of time because each request is taking up lesser power or lesser energy. And for burst, again, it didn't really perform that well compared to
You
HPA.
have 1 minute to conclude your presentation.
Yes, yes. Yeah, so and for CPU intensive, it performed really well compared to the default implementation. The conclusion for our paper is that we propose a new framework to include energy as a primary metric for our decisions, and this is modular and extensible. So we can also go with a hybrid approach. For example, for bursty workloads, you can have CPU HPA as well as energy aware auto scaling complement each other so that you have both energy savings as well as you save latency. And future work that we are looking at is primarily one to scale this to a multi-node framework where you have 4 or 5 systems in a Kubernetes cluster, and then you test this framework on that and see how it can be optimized for multiple nodes. And threshold learning, right now we went with a static baseline, but of course we could go with something that the system itself learns the threshold through some machine learning approach or something like that. And we can forecast the kinds of workloads being deployed in CPU intensive using ARIMA or LSTMs, something like that. And finally, to benchmark this framework against some heavily used applications such as e-commerce or some write intensive applications like ERP software or something like that, that would really be helpful in seeing the rigidity of the framework. And we are the authors here. We are from PS University. Thank you very much. Thank you for your attention and time. Are there any questions?
Yeah, Ronak, I have a question. How does the Kubernetes ensure eventual consistency between etcd and the cluster states?
I'm sorry, sir, I didn't get you.
How does the
Could you-
Kubernetes ensure eventual consistency between etcd and the cluster state?
What is etcd, sir? I didn't get that.
Okay, you don't know. Can you
Yeah.
explain a basic difference between the desired state and the current state with a real failure?
Yeah, so desired state is when the state that you want your replica to be in, and the current state is the state it's operating in currently. So if the power, if for our research, suppose if the power being used by the current state exceeds the current threshold, we add more replicas to it, and then you can reach the desired state by saying, okay, this replica should use only this much energy for this request, and if it exceeds this threshold, then you scale it up so that one replica is not loaded too much.
Okay. Thank you, Ronald.
Thank you, sir. Thank you.
Thank you for your presentation. Next, we have Sandhya, paper titled Deep Learning for Audio Quality Assessment in Music, Models, Metrics, and Challenges.
Hello. Hello?
Yes.
Am I audible, sir?
Yes, you are.
One second, I'll share my screen. Is my screen visible, sir?
No, your screen is. Yes, now it is.
Good afternoon, everyone. My name is Sandhya Rani, research scholar from Sri Ramanand Tirth Marathwada University in Nanded under the guidance of Dr. S.D. Kamitkar. I am delighted to present our research on deep learning for audio quality assessment in music, models, metrics, and challenges. This work addresses a critical challenge in today's streaming era. That is, how do we automatically evaluate music quality in a way that aligns with human perception? Coming to the context, we are living in the music streaming era where billions of songs delivered daily across smartphones, laptops, smart speakers, etc. And users expect high quality audio everywhere. But the technical reality is complex, is complex because of the varying network bandwidth, different audio codecs that is used, and diverse playback hardware which are being utilized. And this creates two critical problems. The first one is how do we ensure consistent quality at a massive scale? And second one is, and mostly fundamentally, I can say, how do we build automated systems that actually align with how the humans perceive the quality? And that's what our research addresses. Coming to the traditional approaches, the traditional audio quality assessment falls in two methods. The first one is subjective method and the second one is objective method. Coming to the subjective method, these methods are used where humans listen and rate the quality of the music, and they are considered the gold standard. They are reliable, but the problem which arises in these methods is they are incredibly time consuming and very expensive. We can't use them for real time quality monitoring on streaming platforms. And in this subjective quality methods, was few subjective listening tests are being used, like mean opinion square. We have Mushra. We have ITU. That is ITU. It's a protocol which has been used for testing, and and ABX testing, etc. Coming to the objective methods, these objective methods use signal processing algorithms like signal to noise ratio, total harmonic distortion, and different perceptual models like PESQ, QOLQA, and PEAQ, etc. Coming to the limitations of these objective methods, they are very fast and automated, but they are critical. That is, it has a poor, they show poor correlation with the human perception, and they struggle especially with complex musical content where the perceptual nuances matter. So we have a gap, and this exactly where the deep learning comes in. Coming to the deep learning provides an elegant solution to this gap. And the key insight here is we can train neural networks on human rated audio data, and these models learn to capture the complex non-linear relationships between audio signals and perceived quality. Unlike traditional algorithms, deep learning models actually learn to mimic human auditory perception, and they are once trained on perceptual data, they are deployed at scale, solving the scalability problem. And even they are adaptable, they can handle the incredible diversity of musical content from classical symphonies to electronic music. And the approach is straightforward. That is, we train on human ratings and learn the perceptual patterns and predict the quality automatically. And in these deep learning models, we have different types of architectures. The first one is convolutional neural network. Coming to the CNN, the convolutional neural network take the spectrograms from the audio, and these spectrograms are given as the inputs. These are the visual representations of audio showing frequency content over time. And this architecture uses convolutional layers to extract local spectral patterns, and the pooling layers in CNNs are used to reduce the dimensionality, and the fully connected layers map these features for predictions like quality scores, etc. CNNs excel at detecting local artifacts like distortions, clipping, and compression artifacts in specific video bands of an audio. However, they have certain limitations, like they're limited only for the temporal context itself. Music quality often depends on how the things evolve over time, like temporal dynamics, rhythm, continuity, etc. And CNN struggles with these context here. So because of this, this motivated the development of the recurrent neural networks. Coming to recurrent neural networks, these networks use long short-term memory networks or gated recurrent units that explicitly model temporal dependencies. And they process audio sequentially, capturing how the quality evolves over time. And along with that, the CRNN, that is convolutional recurrent neural networks, which is a hybrid, is particularly effective. And CNNs extract spatial features from the spectrograms, and then it is being fed to these RNN models. And this RNN model find out the temporal flow of all these features. And this architecture excels at capturing temporal artifacts like audio dropouts, interruptions, or quality fading over time. And these are very crucial for streaming quality assessment mainly. And even the RNNs have their own limitations, like it has gradient vanishing problems in long sequences, and even sequential processing creates a computational bottlenecks. So next, because of these because of these issues, the transformer architectures are being implemented, and we can say that these at present transformers represent the current state of art techniques, we can say. Instead of sequential processing, the transformers use self-attention mechanisms, which allow the model to capture long-range dependencies across the entire audio sequence in parallel. And the models like audio spectrogram transformer, which has shown remarkable performance achieving the best perceptual alignment with human ratings. And not only that, transformers even excel at capturing global context, that is understanding how the quality perception depends on relationships between distant parts of the audio. And even it has certain trade-offs, like it's very costly. Because of this computational cost, it's very difficult to implement the transformers in everywhere. And transformers are memory intensive, and it requires significant processing power, which can be challenging for real-time applications. Sorry. So next is the hybrid networks. The hybrid models combine the strength of the multiple architectures. The typical approach is we use CNNs for efficient local spectral feature extraction, and then feed these features to RNNs or even transformers for temporal or global context modeling. And some models implement multi-scale processing, analyzing the audio at different temporal resolutions simultaneously. And we have found that certain networks like QualityNet, non-intrusive speech quality assessment techniques, and even hearing aid audio quality indexes are being used extensively. And coming to the hybrid models, and the results are very impressive. What we have found is the hybrid models achieve approximately 0.93 correlation with human perceptual ratings, which represents the state of art. This brings us on how actually evaluate these models. Now, this is a comparative analysis report.
You have 1 minute to conclude your presentation.
Okay. So we have found that among all the models coming to CNN, RNN transformers, hybrid models have achieved a best correlation of 0.93, and with this we can say that hybrid models perform much more better. It all depends upon the architectures where it is being used. And other than that, we have evaluation metrics like loss functions, correlation metrics, error metrics, perception metrics are being used to find out the quality, audio quality. And coming to the challenges, despite the progress, we have lots of challenges like data scarcity, subjectivity, and variability. And the deep models are like black boxes where we can't predict the exact quality. At the same time, challenges remain like data availability, model interpretability, and real-time deployment will be a challenge. And future work should focus on music-specific datasets, explainable models, and efficient systems capable of handling complex listening environments. So, thank you.
Thank you for your presentation. Sir, do you have any
No, I
questions?
don't have any question.
Thank you.
So next we have Gurbaksh, paper titled Dynamic and Personalized Interview Preparation System Using AI and NLP Technologies.
Thank you, sir. Let me share my document. Just give me 1 minute. Sir, my PPT is visible.
Yes, you can start it.
Very good afternoon to all of you. I'm very thankful you had given me the time for presenting my work here. Today I am here presenting my one of the work in which we had developed a system which can help the students to prepare for interview in a better way. So we are three authors in this who had contributed. One, Navneet Malik from my university, and another one is from the TAV college. Sir, is my PPT is changing on this?
Yes.
No? Okay. This is the overall things that we are going to be covering in this PPT. The first thing is abstract introduction, literature review, problem statement, proposed system architecture, and the rest of the process, how we had actually implemented all of this. Then we will conclude and definitely we talk about the future scope. If I talk about this system actually try to be cover one of the challenging features which actually the people are looking for. How I can prepare for my interview, even it can help me to be prepare my resume based on to my skill set. How I can make it sharp, how I can make it for a specific job requirement. That is the main motive of this. If I try to be compared with the traditional one, they have a static kind of data which is going to be help me. This system offers a real-time feedback based on to the type of speech the people are using for presentations, their expressions, and whatever the content they had related to the particular job. That is the main thing which we had highlighted here. Definitely, if I look upon my traditional approaches, so they are providing the static kind of practice by which, without caring for, you can search for a particular topic and it is going to be provide you that kind of information. And nowadays, even if you are using the AI concepts, they are helping you for providing a specific kind of data, but this may have a scope still related to how you can interact with the system in a real environment. So that kind of features we try to provide there inside. So we can say the limitation, whatever is there in my traditional approaches, that one. Here we had highlighted how this is. So we use the AI in my web technology, which are helping me to be prepared for interview with the interactive and realistic interview environment. Uh, we need not to be memorize all those concepts, okay, which is the sequence. Let me do as per me, and it is going to be guide me how we can. It can provide me the number of ways by which it can help me out. To reach up to this particular problem, we had literature review, and in which we had seen the work of the researchers, how they had produced. So try to include some of the research paper here in this my presentation. But in my actual work, there may be more, but some of them are highlighted here in this. In 2025, there is one of the paper which is presented by Kotahari and all et al., which integrate actually the analysis of your resume based onto your video, and it is going to be assessed that particular one. If we go down to the line 2024, the mission and other colleagues had presented one of the AI powered tools which can enhance the educations and improving the thinking skills. Help also to the teachers, how they can train themselves and how they can find a better resource to uh, can be used in their classroom. There is another paper 2024 by the same author, whatever it is my first one, which actually provide the real-time feedback and facial expressions. You can say the work is in this directions. There is another paper down to the line 2019, which actually introduced the word and this also use the novel deep learning NLP, uh, which is going to be try to be uh, go into how they can do the analysis with respect to the sentence making and all that. Also in 2017, there are too many people who had worked on an NLP, and they also help for self-retention mechanism. Uh, these are the another literature papers you can see in this, uh, which actually helping either in scanning the resume, they are guiding as per that particular one. And there are some professional tools that are available online. The people can use them for preparing their good resume, or how they can include the skill set with respect to the specific job, how they can prepare their resume for that particular one. So even those are there. Even you can increase your coding skills. So too many online platforms are available, but this is not a kind of, this is a little bit which is going to be improved. Here you can see my problem statement after going through this literature review. I had chosen some of the sentences from my study so that I can highlight what is my. So here we, instead of those digital preparation platform which are available nowadays, we try to be make my system in such a way which can use and help use the AI or some another kind of features there inside on the web, which can help the users for preparing in with a customized feedback. Also keeping in mind what is the job profile for which I am going to be prepared for, and it is going to be give me the through skill development, or you can say help me to be prepared at my own end by using this tool. If I talk about my proposed methodology, so this is the complete methodology in which we have six different aspect which are used there inside, so which actually shows along with my proposed methodology what we are going to be. So the first thing is the user onboarding. The second thing is the analysis feedback. The third thing is where we are targeting, what is my target in my career, how it can help me for preparing my technicals, and then some of the simulators kind of simulations kind of things are get provided to me, which can help me to be are guiding me how we can do that analysis. So this is based on to whatever is available. With the help of the AI, we are going to be gather this information and put forward. And let me see the performance, how this will get increased. So this is the whole flow. Either you can say what will the methodology we had proposed initially. Here we can see the my system architecture, in which we had the layer front end layer, where we had used all these technologies. React we had used some another technology which can help me to be better prepare my front end layer, and can easily interact with, which can provide on the same time with the same kind of involvement of the users. There is the backend layer which are helping me with the different type of techniques which we had used there inside that are highlighted here, whether I am talking about my Express, JS, JWT, or some another that are there in this. AI components, we had used NLP, the computer vision TensorFlow library is used. We had used rule-based recommendation engine also, which speech analysis. These all are helping me how we can prepare as per the whatever the student wanted to be prepared for a specific one itself. These all are the functionality which are provided by the different type of modules. So this architecture actually show me the whole of the way the component design, and by using those component they are indirectly providing me whole of the solution for my this system. This is the flow for my analysis. Uh, Firstly, the document parsing. Then we are extracting the text from here. Let me recognize with respect to what is their education, what is the skill set, what is the experience, and all that. So these kind of parameters are taken into, and also there is a system which is going to be guide them what skill sets are missed as per this specific one. So that is there inside, or you can say the kind of feedback is also get generated. Format analysis to let me improve how we can present myself in a better way. So I am going to be shock myself. Let me show my product in such a way so that it can be as per the requirement of the user, as per the requirement of the people whosoever is providing the job to me. The technical assessment of the workflow, you can
You
see.
have 1 minute to conclude your presentation.
Oh, sorry. Technical assessment is performed by using this problem selection, code extraction, evaluation, and all that. This is my behavior pipelines where we had the audio input, we had the facial expression that we had discussed, and these are all the engine which are supporting me to be help me into that particular one. This is the experimental procedure, which is actually due to the lack of time, I may not be going to the detail of this, but this is a structure approach which having all those kind of things which we had presented in my above architecture. Here, the conclusion, definitely we had included in my system this AI system which can help me to be prepared by incorporating all the different types of aspects so that the user can prepare in a better way. This is a future scope. Definitely, there are challenges. The fairness and trustworthiness among the users can be integrated. We can make with respect to the language specific as per the student needs, which is one of the way suitable way for someone to will learn. These all are the reference. Some of the references we had shown here in this. Thank you. Thank you, and I am happy to take your questions.
Thank you for your
Yeah, it was a nice
presentation.
session. Your presentation was very good. If time permits, then we can also see all the other slides also. No questions from my end. Thank you.
Thank you. Thank you.
So next we have R. Venan Lalapuya. Paper title: Explainable Genomic AI for Predicting Diabetic Mellitus.
Sorry, is my voice audible?
Yes, your voice is audible.
Excuse me. Okay.
You may please begin with your presentation.
Excuse me. Wait. Okay. Good afternoon, everyone. And sir, thank you so much for giving me another chance to able to present my paper once again. And this is my paper, Explainable Genomic AI for Predicting Diabetes mellitus within Mizo community. And these are the authors. And actually, there are doctors are also involved in order to fetch data from the patients. And this is my contents. Introduction will be there, literature will be there, and after that we are also going to talk about how we collect data and experiment and discussion, and results and discussion also will be there, and conclusion and future work and reference also will be there. And first of all, let me introduce why we have proposed these studies. And diabetes is one of the deadliest non-communicable disease around the world, and it's affected 285 million people around the world, and it's believed that the number will go higher to 552 million people by 2030, and it was foreseen that 1 in every 10 person in society around the world will be living with this deadly disease. And the prevalence of this disease have various factors like unhealthy lifestyles, and it also can come from genetics, and also can come from community practices. And like when we talk about unhealthy lifestyle, it can be a poor diet or lack of exercise or physical activities. And like if we talk about genetics, it can come from families. And if we when we say a community, it's also where it include environmental factors contribute to diabetes. And India is also securing the second highest diabetic population globally. And Mizoram is also right now is affected 29.80% of population. So, and the proliferation of genetics and clinical data has rendered it possible for machine learning to improve prediction accuracy, whereas traditional approach depends on statistical analysis and risk factors. Choosing the right features is essential to creating effective and comprehensible models. By using evolutionary principle like GA, genetic algorithm with relief efficiently find the best feature subsets. The reason we are using this genetic algorithm and relief technique is that this technique is going to fetch only the important features. And these are my literature review. I will quickly go pass through the literature review, and I will go through problem identified. So in literature review, we have we have study the existing system of 10. Then out of the 10 existing system, we have identified a problem, that is that the majority of the early research has either prioritized interpretability at the expense of decreased performance, or concentrate primarily on optimizing predictive accuracy without guarantee statistical reliability of the chosen features. So they have actually extracted the important features, but that feature is not statistically reliable because they do not have provide any evidence to prove that their feature is reliable. And another one is other three predictive strength. And other predictive strength are using the healthcare database from repository bank, like from online they have fetched it. But in our studies, we are going to use a data only from a certain people and a certain area, that is Mizoram and Mizo populations. And these studies provide a thorough framework that combines chi-score validation and GA-based feature selection, followed by a SERP-based visualization for clear model interpretation. In order to overcome these gaps, the gaps introduced by the existing system. Okay, so this is the data description. We have collected the data from a patients after collecting their blood, then we have it have to go through biotechnology lab. Then after it have go to the biotechnology lab, then we have a CSV, a clean CSV file. So that is a CSV file is comprises of 84 attributes and uh, 84 attributes, and there are so many rows, right? Around 84,718 variants are there. So from that variants, we have also isolated diabetes and non-diabetes again, and diabetes is around 84,215, and diabetes is only 501. So since we are dealing with a life of people, so we have to be very careful about curating the data. So curating the data is very important, as we are going to deal with genomic characteristics. So later on, I will discuss clearly how we are carrying out in order to have a curated data. This is the proposed method. First, we have a genomic data. After that, we have processed the data, like we are removing the missing values or invalid data, and also we are removing all the noises that can actually decrease and decrease the decrease the performance. And also we have removed the duplicate samples, and also we have removed outliers. And after that, since our data are having categorical data, we have converted into numerical data, numerical category. And after that, we have actually split our data into 20% and 18% by train, and 80% test 20%. Here we have proposed GA plus relief F. This is the hybrid feature selections. And also I have to I would like to include that this is the first studies within the certain population, that is Mizoram, using this AI, XAI. And also we are using SERP-based, and in the feature selection, we also have applied cross-validation. And after we have actually have all the important features, we have apply statistical validation to have a reliable features, since we are dealing with human life. So we have to be very careful, since all the features that we have selected must have a statistical validation. So in order to do that, we have applied this statistical validation. Then after that, we have model training, that is GetBoost. GetBoost also we have applied optimization in order to improve the accuracy. Okay, that is my proposed methodology. Then after that, data pre-processing is very important. Like I said, our genomic data is dimension is very high. So in order to decrease it, and in order to eliminate all the unimportant informations, we have to go through all these things. So to guarantee the full annotation, entries with unclear and missing values were eliminated, and to prevent redundancy, duplicate variants were removed based on the string combination of the target and the SNPs identifier ASP F50. Using these attributes, we are removing missing values, duplicate values, and also to find a trustworthy clinical annotation, we are using clinical disease name. And to support sequence association analysis, only variants that were clinically accessible were kept. And the important population level and functional features were extracted, such as allele frequency, metric including like AF, exact, and genome ID. All these things have been used in order to have accurate data. And numerical value will convert numeric values were converted into numeric forms, and incomplete record were removed to yield a fully numeric. And ML machine learning ready dataset has been formed after removing all this unnecessary information. So after removing all unnecessary information, our data can concluded to of 497 diabetes sample, and 494 with diabetes, including 48. So before we have mentioned that it has 84 attributes. Now the dimension is decreased to 84 attributes. So after we have decreases the
You
dimension.
have 1 minute to conclude your presentation.
Okay, thank you so much, sir. And after we decrease the dimension, we let the doctor checks whether all the important features are important or not, and they have confirmed that all the important features selected by this GA are very important. And these are the experiment discussion. Let me go to the result. And after we have applied the cat boost and light GBM, so these are the accuracy that we have 85 for cat boost. All mean that's GN, GA plus relief. And cat boost alone with GA is 86, and all 80, and light GB GA is 82. Now this is the operation that we have and from our data, and these are the statistical validation from our selected features. And in the significance column we have seen XX, which means that these are the less important, but it doesn't actually decrease the prediction. And these are the B-shown plot that we have. And here all site 2015, it has the highest features attribution to in order to make a prediction. And these are a global feature extraction. These genes reference have contribute more to type 2 diabetes. And this is the conclusion. And conduct the real world and multi-population studies to assess clinical is very important. Since we don't have a time for that, we have if we do have time, it will be actually help people if we can conduct and develop clinical friendly dashboard which serve explanation for practical use and extended frame to longitudinal risk prediction to support personalized intervention. These are my references. Thank you, sir.
Thank you for your presentation. Sir, do you have any question?
No, I don't have any question. Presentation is very good.
Okay, thank you, sir. Thank you so much, sir.
Now, I sincerely thank our authors and for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenter would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. Now, I also thanks our session chair for chairing this session. A token of appreciation to the chairs on behalf of Team ICTCS 2025 and a Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Sir, would you like to share a quick closing remark with
It
us?
was indeed a great session. I liked the session. Every presentation was indeed good and on a new topic. All the presentations are good. All the presenters are good also. Thank you, Shashwat, for giving me the opportunity to see all the presentations. Thank you very much, Shashwat, and thank you very much, ICTCS, as well as the GR Foundation. Thank you very much.
Thank you, sir. I kindly request you all to switch on the cameras for a quick snapshot of a virtual conference. Thank you. Stay safe and take care.